Look at your wrist, and you're likely to find a wearable smart electronic device, such as a Fitbit or an Apple Watch. Smart electronic devices like this have had a massive impact on our health, from tracking how much standing we do in a day to helping us set daily exercise goals. The newer ones can even track your blood oxygen content and your heartbeat. By tracking our health more efficiently and more accurately, we can determine issues sooner, with early detection being a key to treating so many illnesses. However, wearable electronics like these are currently being made with precious metals like silver or gold, which need to be mined from the ground and are not in great supply. Metals also have the added challenge that they form very rigid materials, which limits how flexible we can make our wearable electronics. Look at your watch again, and you will see it's time for a change. We need to look for alternatives that are made using more environmentally friendly materials. Carbon can be found everywhere. It's in the trees and the plants, and is the most abundant element on Earth. Carbon chemistry has a lot of choice, which for me, a chemist, means I can design materials with more desirable behaviors. Carbon also doesn't form such stiff bonds. Therefore, we can use it to make more flexible wearable electronics. My research looks at designing materials that are made up of mostly carbon that can be used for electronic films. I start by dissolving my materials in water, which is an abundant and environmentally friendly liquid. I then pour my liquid onto a surface and let it dry into my electronic films, which can then later be incorporated into electronic devices. The conductivity of my materials can be changed either by changing the pH of the water it's dissolved in or by changing its chemical structure. You can think about my materials like beads being dumped onto a table. Individually, they're very small and they just scatter into a mess. But when I change the pH from 7 to 3, it's like stringing a thread through the beads to create a stylish bracelet. By stringing them together, they stack more uniformly, which improves how conductive they are. Alternatively, I can change the structures of my chemicals, like changing the beads from red to blue. Then that changes how they stack together and how conductive they are as well. I can then pour my dissolved materials onto a surface to let them dry into lovely electronic films like the ones you see on my slide, giving me an array of different beads to use for my design in the next big thing in wearable electronic fashion. Thank you.